Welcome back to the Deep Dive. Today we're looking at something that I think is on every software leader's mind right now. It's this promise of agentic AI, these systems that can truly autonomously manage complex goals. But, and this is the big but, moving from a really cool demo to something dependable, something maintainable in production. Well, it's proving to be a bit of a nightmare. And that's exactly why our deep dive today is focused on a technical guide that's becoming, frankly, an essential engineering blueprint. It's called the Agentic AI Bible, the complete and up-to-date guide to design, build, and scale goal-driven, LLM-powered agents that think, execute, and evolve. It's by Thomas R. Caldwell. So our mission is pretty simple. We want to extract the core wisdom from this book. The book's whole argument is that agent-based AI is the next big thing, the next truly disruptive phase of software. But only if we start treating it like serious engineering. We're looking for that roadmap to get these agents out of the lab and into real, high-stakes enterprise systems. Okay, let's unpack this. Caldwell is writing for a very specific audience here. He's targeting the builders. The people with actual budget and responsibility, engineers, system architects, AI product leads, the folks who need solutions that actually work, not just theoretical prototypes.
Right. And he starts by giving that audience a really unflinching look at the current state of things, which he calls the agentic gap. What's so interesting is that agentic AI isn't some far-off dream anymore, but the process of building it right now is just chaos.
The agentic gap. I like that term.
It's this huge chasm, between the incredible potential we see in these little proofs of concept and the robust reality you need for a real deployment. Technical leaders are struggling because there's just no systematic, repeatable way to do this yet.
And the book gets right into why this chaos feels so painful and expensive, which I think anyone who's tried this will find incredibly relatable. We're talking about these prototypes that are brilliant in concept, but they're so bloated they just can't scale.
Yeah.
The minute you hit real volume, they crumble.
Completely. And it gets worse. The tools you need, like, say, a code interpreter or a vector database, are often just duct taped together. That's his phrase. They don't share state properly, which leads to this incredibly brittle behavior. So an agent might, finish step 1 of a 10-step plan perfectly, but then it fails on step 2. When it tries to backtrack, it's completely forgotten the context of step 1. That lack of a recoverable architecture. It's a fundamental flaw Caldwell is trying to fix.
And that means there's just zero visibility into performance. You can't debug it, you can't verify its reasoning, and you certainly can't audit it. And that's an absolute deal breaker for any regulated industry like finance or healthcare.
Exactly. And this failure to scale and maintain is why the book has landed so powerfully. It basically promises to answer the 3 big existential questions that every tech leader in this space is asking.
Okay, so what's the first one? It's got to be, simply, how do we get past those flashy but fragile demos and build genuinely dependable systems that, clients and auditors can actually trust?
That's number 1. Number 2 is about orchestration. This isn't just about having a powerful LLM. It's about how you orchestrate all the moving parts. The agent's perception, its reasoning, its actions, all within a complex, changing environment. The real world isn't a single text prompt after all.
Right. And the third question, this is one that's both exciting and a little terrifying, and it goes right back to the book's subtitle. How do we design agents that can really think, execute, and evolve? While, and this is the crucial part, making sure they stay safe, observable, and maintainable. If you think of those as the 3 guardrails, getting them right is what separates a science project from a real platform. So this agentic gap, this chaos, it sounds expensive and honestly dangerous. How does Caldwell propose we move from duct tape to actual engineering? It has to start with the architecture.
Absolutely. If the gap is the problem, then the blueprint is the architecture. Caldwell really insists on a full lifecycle approach. You can't just think about the model. You have to engineer the entire framework that the model lives inside. He says you have to design agents with reasoning, memory, and planning from the ground up. They can't be afterthoughts.
Okay, but what does that really mean? Everyone talks about memory.
Right, but what's fascinating is how he defines it. Memory isn't just a database of past chats. He sees it as a structured system, a specialized module that indexes and abstracts information. It allows the agent to recall concepts and relationships, not just, raw text.
Wait a minute, though. Everyone talks about planning and memory. What makes Caldwell's approach to embedding reasoning so different from, say, what we see in open source frameworks? Is he just renaming old computer science concepts?
That's a great question, a necessary one. The difference is the modularity he advocates for, the explicit separation of concerns. He proposes these architecture patterns where the LLM is the reasoning engine, but you externalize the planning and the state management into their own dedicated systems.
Oh, okay.
This means you can upgrade your LLM to the latest, greatest model without completely shattering the agent's ability to track a long-term goal. It's about building a robust operating system around the brain instead of asking the brain to do everything.
That externalization of state.
Yeah.
That sounds like the key for maintainability.
It is. And the next critical step, the one that gets you past simple prompting response, is implementing what he calls the 3 loops: perception, action, and environment loops. This is the core mechanism that lets a system genuinely interact with the world instead of just answering isolated questions.
Okay, can you give us a more tangible analogy for those 3 loops? Because that sounds like pretty dense jargon.
Sure. Think of it like a human manager on a project. The perception loop is the manager gathering information, checking email, reading status reports, looking at a dashboard. The agent takes in raw data and turns it into structured knowledge. Then the action loop is where the manager decides what to do. They assign a task, they send an email, they trigger an API call. It's the execution. But, and this is the key, the environment loop is the feedback. The manager watches to see if that action actually worked or if it caused a new problem. It's that constant monitoring of reality.
So it's not just do this. It's do this, watch what happens, and then adjust the entire plan based on the outcome. That feedback cycle is what you need for real autonomy.
Precisely. And once you have those loops working, the book moves to the evolve stage. This is where he introduces advanced behaviors like recursive reasoning and self-reflection.
Recursive reasoning. That sounds like something straight out of science fiction. How does Caldwell define it for an engineer who actually has to build it?
In practical terms, it's the agent's ability to deal with a roadblock by creating a temporary sub-agent to solve it. So, let's say your main agent is building a financial model, and it hits an API error it can't fix. It doesn't just give up.
It spawns another agent.
It pauses its main plan, launches a specialized diagnostic sub-agent, and gives it one simple task: fix this API connection.
And that sub-agent solves that one specific problem, reports back, and then the main agent just picks up where it left off. It's like self-delegation.
Exactly. It breaks a huge task into small, solvable pieces, and self-reflection is like its own internal audit. The agent can review its own decision history, identify patterns or inefficiencies in its own logic, and then use that to refine how it makes decisions in the future.
Which then leads to goal reprioritization. So the agent isn't just mindlessly following a script. It can sense a major change like the budget just got cut or a deadline moved up, and it can actually adjust its own priorities. When you have an agent that can do that, that's when autonomy gets real.
Okay, here's where it gets really interesting for me. Once you have this sophisticated adaptive design, the biggest hurdle for any large company is going to be reliability, safety, compliance. If you can't trust it, you can't deploy it.
That's where the rubber meets the road. And Caldwell spends a lot of time on this, on moving from brittle systems to trustworthy ones. He outlines what he calls 3 secret design strategies for safety, reliability, and testability.
Can you give us a peek behind the curtain on one of those? That's the kind of practical detail our audience is really looking for.
Certainly. One of the biggest safety strategies is the principle of decoupled planning and execution. A lot of brittle agents use a single LLM call to both generate a plan and execute the code for that plan. That makes it almost impossible to add guardrails.
Caldwell argues you have to decouple them. You use one specialized, constrained LLM for the high-level reasoning, but that plan gets passed to a totally separate, hardened execution agent. And that second agent validates every single action against strict safety policies before it's allowed to run.
So the planner is like the CEO setting strategy, but the execution agent is the strict compliance officer who double-checks every single order. That separation prevents one bad prompt from causing a catastrophe.
Precisely. It's defense in depth. And then there's the question of impact. An agent that's just talking to itself in a sandbox is, useless to a business. So the book really hammers home the need to connect agents to external tools and APIs through what he calls robust tool manifests.
What's a tool manifest?
It's more than just a list of functions. It's a structured, self-describing interface that tells the agent the preconditions and postconditions of every action it can take. That's what lets them handle truly complex, multi-step tasks that deliver real business value.
And once it's deployed, you have to manage it. You can't just set it and forget it. The governance part is critical.
Oh, absolutely. The guide details 6 benchmarking frameworks and evaluation metrics for this. And these aren't just about accuracy on a static test set. They're designed to measure 3 things in a live environment. First, intelligence. Did it actually achieve the goal? Second, robustness. How did it handle errors and weird inputs? And third, operational readiness. Things like cost, latency, and how quickly it can recover from failure.
That brings us full circle, really. The scope of the book is that entire engineering life cycle, from architecture to safety to governance. The breadth of application is also worth hitting on. He provides real-world examples across different industries. For finance, there are blueprints for automated fraud detection agents.
And beyond finance, you see architectures for robotics, for industrial automation. It covers business workflow orchestration and even advanced healthcare tools for diagnostic support.
So it's not just theory, it's showing where this tech can actually move the needle right now.
And if you look at the table of contents, he makes sure leaders are ready for the whole ecosystem. There are whole sections on multi-agent systems, so how you get different agents to cooperate, plus dedicated chapters on security, on the evolving legal landscape.
Wait, he covers the legal aspect.
He does. There's a risk management playbook, insights on human-agent collaboration. It's really a 360-degree view of what it takes to deploy this successfully in the real world.
So what does this all mean? At the end of the day, the core value proposition for you, the listener, is that the Agentic AI Bible really is a complete engineering blueprint. It's the guide for professionals who are serious about moving past academic toy projects and delivering robust, goal-driven agents that actually perform at scale.
Right. And the subtitle promises agents that can think, execute, and evolve. We've talked about the technical guts of that recursive reasoning, self-reflection. So if the biggest challenge for technical leaders today is making these advanced agents observable and maintainable, then the next question for you, the person designing these systems, becomes much deeper. Once you have a system that is truly capable of self-reflection and dynamic goal reprioritization, how much autonomy are you actually willing to grant it? That blurring line between control and capability, that's the future we're building right now.